All right. Good evening, everyone. So today we'll be talking a little bit. I think this is probably the most esoteric topic for today. Let me just quickly get started. Okay. So it's a quick introduction about me. I'm an entrepreneur. I work with ROS, Web, and Cloud. I've added a bunch of links where you can reach me online. Okay. Now let's try to define the problem. Okay. Thank you. Is this okay? All right. So, is there a problem? That's the first question, right? Is there a problem? Depends on where you are in your process, depends on how you work. Maybe there is no problem. But the way I am working with, the systems I am designing and using, state, if you hear a lot of these software engineering talks, you'll keep hearing about state. State happens to be a big part of what I deal with. And it's fundamentally very hard to deal with state if you don't architect a big system. If you are just doing small systems, small experimental systems, state is a big problem, right? And then the other part is I tend to build in increments. Of course, everyone builds in increments, but what I mean is I tend to compose stuff. How do you compose stuff? You build one function, you build another function, which is calls the previous one. So it keeps building on top of each other. Okay, so I don't know how many of you here, because most of you are still in college, I don't know how many of you here know ESR. Eric Raymond was one of prolific programmers. I mean, he is. This is a quote I came across from ESR way back in 2005, 2006. It's one of the reasons I started learning Lisp. And there are a few things in this. I mean, the reason I started in that is the fact that, he said you could experience enlightenment. I don't know if that is true, but it definitely makes you a better programmer. So whoever is not, you should. By a quick show of hands, are there any Lispers in the room? Okay, the talk just got super esoteric. All right. So even amongst Lisp, Clojure is a very specific type of Lisp. I would like to call it a practical functional Lisp. So when I write code in multiple Lisps, when I was working with ROS1, I used ROS Lisp almost exclusively. But ROS2 doesn't have a ROS Lisp yet, or RCL Lisp yet. So I thought, okay, why not? Anyway, there is no binding. I might as well choose whatever Lisp I want. And I was doing a lot of transformations, so I thought, why not use something that's functional, right? This is how Rich Hickey defines Clojure. Rich Hickey is the one who wrote Clojure. There are two things that are worth noting in this. The first is the fact that it follows the code as data philosophy of the Lisp, which is important. How many of you guys use behavior trees in ROS2? Okay, so code as data is, what is code as data is, currently if you have a behavior tree, you need a runner. You need a tree runner to actually run the behavior tree. But if you have a code as data system, the behavior tree can run itself, right? It's somewhat mind-bending, but that's what code as data can do for you. And secondly, Clojure is a predominantly functional language, which is important because it doesn't get very pedantic about how you do things. Okay, but Python does everything, and you have fantastic RCL Pi bindings, and you can do almost everything I'm doing with Python already. And I think the XKST comic really captures everything. You can potentially in Python, you can just do import Clojure and run a Clojure REPL right inside Python. I mean, you can. I'm not even joking. It's a fact. You can do it even as of now, right? So these are the most common responses you get. You can do all of this in Python, but there are a few fundamental differences between how you would write Lisp versus how you would write most other programming languages, right? Now, this is not to say this is exclusive, this is how you do it. You can do any of these in any other languages also. But just that, what is the idiomatic way of doing it? So if you took a programming language like Python, you would architect your entire system, identify all the modules, identify all the interfaces, and then start coding them up. Same with C, same with C++, same with Java. But if you are working in Lisp, you tend to work in compositions. You tend to build up the smaller components first, iterate over them, and then build bigger systems on top of it. So what that means is the Lisp system gives you extensive state management, which you would otherwise have to manage yourself, right? So this is something that you will probably not get for free in Python. So even if you can do functional code in Python, you really won't get this kind of state management in Python. Okay, so I think I set the stage for what we're going to do. The how is there are three approaches I identified as to how we can do how we can integrate the ROS2 with Clojure. The first is the RCL Java bindings. How many of you are familiar with RCL Java? Okay, so apparently the project does exist. Clojure runs on the JVM. Clojure is what is called as a hosted language, which means it runs directly on the JVM. And RCL Java, the project already exists. And ideally, I should just be able to write very simple wrappers to RCL Java and get the whole thing to work in Clojure. But I really couldn't get it to build. So anybody who uses RCL Java, I really want to talk to you guys. Right. The next, of course, is we'll fall back to Python. There is a nice Python bridge for Clojure. There is a fantastic data science community within Clojure. These guys went ahead and wrote what is called as a FFI bridge to Python, between Clojure and Python. What they do is basically they have their data in Clojure, and then they just call their learning algorithms in Python or deep learning algorithms directly using Python, instead of having to rewrite everything in Clojure or Java. So it turns out this thing is a piece of cake to use. And although it feels a little cheating, just now I said you can't do this in Python, you can't do that in Python. You still, even by cheating like this, you can get the entire state management powers of Clojure or a Lisp and still keep using Python for the RCL parts. The only problem though, RCL_PY is already an FFI layer. If you know how RCL_PY works, it's already building an FFI layer into the RCL library. And then the libpython is another FFI layer on top of that. While there is no particular penalty to doing this, the order of complexity that introduces when you do something like this is very hard to, especially when you have action clients and you have futures and things like that, things completely get out of control. And lastly, I'm kind of trying to build a completely native FFI binding, whereby I will try to write bindings in Clojure to directly call RCL, which is actually the purpose of RCL. If you think about it, that's one of the intended reasons why ROS came up with an RCL layer, where every other language, any other system that wants to use ROS should directly just implement the RCL bindings. So, like I said, RCL does almost all the heavy lifting. It's already fantastic. But the problem is JVM is a sandbox. JVM is actually extremely powerful sandbox, and that's why it's so popular in the enterprise world. To the extent that if you want to do something outside the JVM, it's fairly hard. I mean, it's possible, but it's fairly hard. And they have what is called as a JNI interface. There is a bunch of, I think it's called a JEP or a JPEP or something like that, where they have defined what this interface would look like. And there are two predominant standards, the Java Native Access and there's something called the Project Panama. So I'm trying both. As of this talk, the thing is still very unstable. I haven't released it, but I have a version using the libpython that I have made available in GitHub. Okay, I have a quick demo. I don't know if we can play it. it's mute. I don't have a sound. I didn't know how it's going to work. So just. Oops. Oh, I didn't. Are you guys able to see this? Okay, I'll probably share the video later. So what I'm doing is basically just I'm bringing up a Docker container with Humble, and I have a Clojure REPL running inside the container, and I'm just writing some libpython code from inside Clojure. That's all I'm doing. So what you see on the right is a Clojure REPL. And all of this is actually basically just RCL py calls. They're not really, there's nothing fancy yet. So I hope I hope it is understandable. I'm just defining a simple standard message, string message, and a callback function to use with the publisher and the subscriber. It's just a simple talker listener example. It's just 101, ROS 101. Right, so you can see a chatter topic. And you can see there's one publisher and one subscriber to that. Right, so there's a publisher and a subscriber. Then you can just do a simple publish call, which would publish the message, which ideally the listener should pick up, the subscriber should pick up. Right, so you can see the subscriber picks it up, and then I'm just going to throw it into a loop. Now what you see there is the state. There is a publisher thread, there is a subscriber thread, and there is a RCL node running. All this is the state of the system, right? Apart from the variables and things. Now let's start going and modifying the system. So you see, I just hot compiled one piece of code, and you can start seeing it reflect immediately. This is something you cannot do in a non-Lisp system, right? Why is that useful? It's very useful when you're doing a lot of testing. You have brought your system to a certain place and then you're testing something. You don't have to recreate the state every time. All that interference is ChatGPT. So see, the cool part is the fact that I'm modifying the function while the system is still running, right? I've been writing Lisp for at least 5 years now, and this one gets to me every time. I'm just jumping every time. You really can't do this in any other system. Okay, I think that's all for the demo. Okay, so any questions you can hit me up, or yeah, I don't know if we have time for questions. We have 34 seconds.
We can quickly take one if there's any. Okay.
Oh, that's nice. See, like I said, I was doing a lot of transformation math, and math is functional. So it kind of maps 1:1, right? You can write Clojure code like you would write a mathematical function. I mean, you can do it in Python also, but it's not truly there. It's still lacks in. I think that's one, definitely. The other one is the way I work, right? So like I said, I'm running one inside a Docker container. Sometimes I run it in AWS, and then I want to hook up I want to debug something that's already running. Then a Lisp or a Clojure allows me to just hook me up into a running system and start inspecting the state, which you can't really do elsewhere unless you have extensive debugging enabled.
So I think for any more questions, you can feel free to reach out to Abishek, and he'll be around here to sort of get it through. So thank you so much for the demo as well in the entire presentation. Thank you.